Hi, this is Darryl Lewis-Sandy from Mana. Welcome to the second of our tutorial videos for the physical quantity service. The physical quantity service is a GraphQL-based microservice which provides the utility to parse and extract physical quantity mentions from strings, to convert between units of measure, and to perform arithmetic with physical quantities in a way that it respects their physical dimensions. This series of videos uses a Workspace service template which contains all of the lessons that we'll be working through. If you've been following along on our previous videos, you will have already created a copy of this template. If you haven't, take a moment now to clone your own copy of the Physical Quantity Tutorials template. Today we're going to be working through lesson number 1, Parsing of Strings. And if you open that knowledge graph, you'll find that it's already been pre-populated with the kinds and functions that we might need to use in this lesson. For this lesson, we'll assume that we have some kind, called observation, where physical quantities have been entered in as uninterpreted text values instead of physical quantity structures. And the goal of this lesson is to convert them into physical quantities. Before we get into the lesson, let's take a look at the text processing functions that the physical quantity service provides. The physical quantity service has 5 text processing functions: parse, parse many, parse unit, parse many units, and extract. Given a string that's a surface form of a physical quantity, the parse function will return the corresponding physical quantity. If the parse function is given a string that isn't a surface form of a physical quantity, then it'll return a null value instead. The parse function can tolerate a wide variation in the representation of the magnitude and the unit of measure that it's given. For example, it can parse natural language numbers, mixed fractions, and scientific notation, as well as decimals and integers. For the units, it can tolerate natural language units, commonly used abbreviations, as well as units in non-standard form. When you have a string that contains the surface form of a unit of measure, you can use the parse unit function instead. When you give it a string that is a valid surface form, it will return the corresponding unit of measure. Otherwise, it will return null. When you have a list of surface forms for physical quantities or units of measure, you can use the parse many or parse many units functions to convert them into the corresponding structures. These functions will take a list of surface forms and return a list of the same length, and any elements that fail to parse will return null. The extract function is designed for extracting multiple physical quantity mentions from a single string. For example, it can find all of the physical quantity mentions in a text document or web page. This function will be the topic of a future video. Let's get back to the exercise for this lesson. As you recall, we're going to try to parse physical quantities out of observations. If we look at the observation kind, we can see that it has an ID, which is kind of the name of the thing that was observed. We've got a value that contains a surface form for a physical quantity. We need to implement 2 functions: the parse observed value function, which parses a physical quantity from the value field of an observation, and the project value from observation function, which is a projection function that, given an observation, returns the value. Why don't you pause the video here and come up with your solution to this exercise, and I'll be right back with mine. Welcome back. So I hope you had a chance to create your own solution to this problem. Right now I'm going to walk you through my solution. So we need to create an implementation for the parse observed value function. So I'm going to start by opening up the function graph for that function. So I know that inside this function I'm going to need both the parse function and the project value from observation function. So I'm going to start by dragging those into the canvas. Now, we're given an observation, which has an ID and a value, It makes sense to apply the project value from observation to that to get a string that we can then pass into the parse function. So let's go ahead and wire that up. So the parse function returns a physical quantity, which is what we're trying to return for the parse observed value function. So we can wire that up as well. Now the only piece that we have yet to implement is the project value from observation. And this is a simple enough function that I'm going to implement that using a lambda. And that's it. Hopefully you had something similar to that. All right, let's try it out. So I'm going to select the function and open the run dialog. And we can go ahead and start by choosing one of the instances that's in the observation kind. Oh, let's do this one here, airspeed. And when we run that, and look at the function results, we get a physical quantity, 400 miles per hour, magnitude of 400, unit measure, miles per hour. Notice that it's been normalized from the original abbreviation of MPH, the customary abbreviation. And it's extracted two factors. One is miles, and one is hours. There we go. And we have conversion factors. Everything has been inferred correctly. That's great. Okay, let's try another instance. Let's try this one here where it's got feet spelled out. There we go. And it parsed it properly and normalized the unit symbol to FT. We got the correct conversion factor. And the dimension is length. That's great. Okay, let's do something a little crazy. We're going to do some natural language units. We'll do 18. And let's do barrel, which is bibble per day. And see what happens. So now we're using units of measure from the oil and gas domain. And we could see that it took the natural units and turned it into an integer, and it parsed barrel just fine. Great, awesome. And it even has the conversion. It knows its volume, and it has the correct conversion to the SI unit. All right, one last one. We'll try mixed fractions. So we'll do 1 3/4 foot-pounds. So that's we got a mixed fraction here and a unit of torque. We run that, and what do we get back? We've got 1.775 foot-pounds, which is what we'd expect. All nicely normalized into decimal format, and then the customary abbreviations for the units. And when we look down into the factors, it's reconstructed all of the information about the physical dimension and unit conversions. That just about does it for today's lesson. I hope you've enjoyed playing with the physical quantity parser. In our next lesson, we're going to expand on this topic and look at how to add constraints to our parse so that we can limit the results to a particular system of units or a particular physical dimension. I hope that you'll join me. If you enjoyed this video and want to learn more about the physical quantity service, don't forget to subscribe to the Mana Inc. YouTube channel